Like terms are algebraic expressions with the same variables and the same exponents for each variable. This is a review from last year. You did this a lot last year, but we just want to make sure that we're okay because as we move further into algebra, we're going to just have to use this skill in nearly everything we do. So if we look at this first example here, it says that we have x squared plus 3x plus 4. And notice that that is inside of parentheses. We call that associated. Those three terms are associated together, separated by those addition symbols. And we have another set of terms associated with each other over here, x squared plus 4x plus 3. Now that's one expression, but these terms have been grouped in some way. So we've got that plus sign in between, we've got these parentheses, and we have to remember what those parentheses are telling us, that those are grouped together. So I like to think of this in a couple ways, but if we look at this first thing that I do here, this first method that I use, I just took that first associated group of terms and I rewrote it as x squared plus 3x plus 4. And then I think back to how I did addition for a long, long time in elementary school. I took one number and I put it on top of the other number. Well, we can do that in algebra as well. We can take one group of terms and put the other group of terms lined up underneath it so that notice that that x squared and that x squared, those are like terms because they're the same variable and the same exponent. Same thing with these 3x's up here and these 4x's down here. They're the same kind of term because they have the same variable as well as the same exponent. And then our constants over here, the constant number 4 and the constant number 3 are right there, and everything is lined up so that we can simply know that there's one x squared up here, there's one x squared up here, so one here, there's 2x squared. Over here we've got the same thing, we've got 3x's and 4x's. If I have $3 and someone else gives me $4, I've got a total of $7. So if I have 3x's and 4x's, I'd have a total of 7x's. With our constants, we've got 4 here, 3 here, so a total of 7. We could look at this in a different way as well, because sometimes it doesn't always lend it well to put it on top of each other. Sometimes when we're solving equations, we want to write that on a single line. And if you think back to solving those 1 and 2 step equations from previous school years, a lot of times when we did inverse operations, we wanted one line shown so that we could keep our work organized. So I just rewrote this as x squared plus 3x plus 4 plus x squared plus 4x plus 3. I did that by unassociating or taking those parentheses out. And it just said outside of that parentheses there was just this, there was nothing written, which implies the identity property of multiplication. There's just one group here. So I just rewrote it as one group of x squared plus 3x plus 4, and I did the same thing with that second group of terms. When we do that, we have to have a system for keeping track of which terms we've accounted for. So I like to use a single line underneath the first term that I'm looking at. And I see an x squared here and an x squared here, so I underlined it once, and that's a total of 2x squared. If I came down to the next set of terms, I underline this as I've got 3x's here, so I just underline it twice because I'm dealing with the second simplified term. And I see another x term over here, so I just put 2 underlines underneath that, and I'd have a total of 7 x's. For the final part of that, our constants here, I can just have that under. We have this 4 here and this 3 here, so I underline it 3 times because that's the number of that's the third term in our simplified expression. If we continue to look at this here, I'm going to show you one other example that looks very similar to what we were doing here. And it says that we have 3x squared minus 2x plus 7. And Associated with that is, with addition, is the negative 3x squared plus 4x minus 7. If I show you just like I did in the last example, we could put those two groups of terms on top of each other by lining up the x squareds, the x's, and the constants. And when we do that, we see that 3x squared minus 3x squared would be 0 because opposites always make 0. And here too, the constant terms, 7 minus 7. Opposites always make 0. That's from our work with integers. We know that opposites always make 0. So a lot of times we clean up a simplified expression by simply writing 2x in this case. We don't always write 0x squareds. Not that we can't write it, but the identity of 0 says that we don't have to write it. Getting rid of those parentheses, we could rewrite that expression. There's just one of these groups. So I just rewrote that without parentheses. And doing the same thing that we did before, we're going to simplify or combine those like terms together. And we see that we're just left with 2x's even in this case, because there's a 7 here, there's a negative 7 here. In our final example, we've got some associated terms, but we have a negative 3x here plus 9. Now in this case, there's a minus sign out here, or we learned from a previous work that that minus sign could mean the opposite of. So whatever's inside of this group here, we could say the opposite of 5x squared, the opposite of negative 6x, the opposite of negative 1. So the first group of terms here is simple enough. We could just unassociate. We could just say negative 3x plus 9. It was one group of this that's just like the previous two examples. If we look at the second part though, we can see that there's that negative symbol out there. A lot of times I like to write that as a negative 1. Even though it's the opposite, that 1 is always there. It helps me keep track of stuff. So I'm going to use this generic rectangle example that may seem familiar to you. Otherwise, I just want you to think about the area of a rectangle as length times width. So I'm going to break this up into 3 parts because there were 3 terms inside the group. And then I'm going to make our dimensions as negative 1 by 5x squared by negative 6x by negative 1. And then I think area equals length times width. So we've got negative 1 times 5x squared is negative 5x squared. Negative 1 times negative 6x is 6x. And negative 1 times negative 1 is a positive 1. When I write this over here, I take this and I chose to separate this. Think of your integer work. A lot of times it's nice to separate with the addition symbol just to keep track of your terms, and that makes us remember that that negative symbol belongs to that coefficient 5, the opposite of 5x squared, plus 6x plus 1. And we can then see that if we underline those terms again, if we underline that first term, that highest ordered term, that negative 5x squared, there's only one term that has x squareds in it, so we simplify that as negative 5x squared. And the 3x's here, we had negative 3x here, we had 6x's here, so we can simplify that as 3x. And then there's a constant 9 right here and a constant 1 over here, so we can combine those like terms together and get a 10. So just a quick review on combining like terms, some different examples from that. That's something that we will do as a part of everything from this school year. So make sure that your skills are well equipped to move forward. Combining like terms.